dear professor and my friends. Today I will talk about Baseband M-ary PAM Transmission systems. As you see these topics, there's some questionable subjects on there. For example, first of all, what is the baseband and what is the PAM and what is the baseband transmission? When I taught it and I searched a little examination of these topics. And firstly, what is the baseband? In baseband is an adjective that describes in signals and systems whose range of frequencies is measured from close 0 Hz to cutoff frequency. And this is the baseband definition. And the second question is, what is the baseband transmission? Baseband transmission is also known baseband modulation and aims at transferring a digital bit stream over a baseband channel. In our third question, what is the PAM? PAM also means pulse amplitude modulation. And I want to talk about some analog and digital systems. In our world and environment, we have got analog signals and analog systems. And in our projects, we want to work with digital signals and digital projects. Let's see a little example of PAM. For example, I have a sinusoidal signal. I have an analog signal and I want to translate it. This is my original signal. When I choose one point on this sinusoidal waveform and other points, I can choose it. And when I look the x coordinates in these points, and these points are my digital signal, and this is my PAM signal. And PAM signal, as you see, is a form and signal modulation, where the message information is encoded in the amplitude of a system. In PAM systems, we use the baseband transmission. For example, we can use PAM systems in lighting emitted diodes, and some defines, for example, IEEE 802.3 defines we are using PAM signal systems. And let's look at our definition. To transform an analog waveform into a form that is compatible with a digital communication system. We are using M-ary PAM transmission in digital communication system. And you see M-ary PAM transmission is a type of digital modulation. This type of modulation results in reduced channel bandwidth. Sometimes two quadrature carriers are used for modulation, and we can call its names quadrature modulation. And the next page, we have a table. I think this is the heart of M-ary PAM transmission. This table defines baseband binary data transmission systems. And we have got a source, and we have got input binary data, as you see, VK. VK consists of symbols 1 and 0. As you know, we are using digital systems. And our VK comes pulse amplitude modulator, and VK and with clock pulses, our VK data changing AK. Pulse amplitude modulator produces binary pulses, and our changing data AK, if our symbol BK is 1, our AK plus 1. Another way, if our symbol BK equals 0, our symbol AK is minus 1. And AK are changing data and comes to transmit filter. And output again changing ST function. ST is modified as a result of transmission to the channel of impulse response. Our impulse response you see HF. In the channel, what can do the channel? The channel adds random noise to our signal, and our signal changes HT, and HT now our noisy signal. At last, HT comes to receive filter. We saw that QF. When HT comes to receiver filter, and it's again changing YT function. And the last of this table, the YT function comes to decision-making device. And decision-making device one threshold lambda. And there's a problem.
Don't worry.
Lambda. And the threshold amplitude of each sample. Threshold is amplitude of each sample. And our YT is changing our output binary data. If our YT greater than lambda, and lambda threshold defines, our decision-making device say 1. If our YT smaller than lambda, our decision-making device say 0. And this is our baseband binary data transmission system. The other page, I'm talking about M. What is the M? And we are using a big M. In M-ary PAM is a multi-level signaling where each symbol takes one of the M allowable amplitude levels. We are using M-ary pulse modulation with non-binary symbols. This is big M, our symbols, and must be greater than 2 because we are using bits. I am talking about this subject, M-ary pulse amplitude modulation, and this subject defines M-ary pulse modulation. M-ary data transmission system uses M encoded symbols. Let's see this page. If M bits are used for a single symbols or waveform, MPM needs M equal to power N. What is the meaning of this defines? For example, for M equals 2, 2 again equals 2 power 1. This 1 is our smaller M. And we can say that 1 bit is used for a single waveform. And we have got big M equals 2, and we can write it 2 PM. As you see, 2, we can change M. Let's look the other example. For M equals 4 and equals 2 power 2, we are using 2 bits are used for a single waveform, and we can say that 4 PM. And here is the definition. The output of the line encoder takes one of M possible amplitude levels with M greater than 2. And we have got signaling rate 1 over T. It defines symbols per second or both. We are using this equation to solve our questions. T equals TB log 2 log 2 M. And what is the meaning of this equation? And maybe we can say something about that. And here is my definition. And here is my equation. And 00, 01, 10, and 11, my 2-bit gray code. you know 2-bit gray code. I want to explain the part of it. And this is my gray code. And 2 power 2. I have 4 gray code in 2 bits. And this is my gray code table. For example, I can write 3-bit gray code. And 2 power 3, I have 8 bits in 3-bit gray code. And this is my 3-bit gray code. We thus see that each symbol represents 2 bits of information, and 1 bound is equal to 2 bits per second. And I'm talking about 1 bound. What's the meaning of 1 bound? Bound is equal to log 2. This definition. And bound is synonymous to symbols per second or pulses per second. And T is my M bits per second. And I am using TB. TB M-ary PAM system is related to the bit dilation. And big M, you know, and the strict amplitude level, and must be greater than 2. And equivalently and statistically independent symbols with the symbol duration denoted by T seconds. And here's the end of my part 1. Thank you for listening.